So now let's understand the Bayes theorem, but before that let's understand with an example so that Bayes theorem starts sounding simple to us. Uh, if you are from India and if you watch cricket match, you must have heard this name called as Sachin Tendulkar. People who don't know him, he is one of the famous cricketer in Team India, and basically he is famous for hitting a lot of centuries in cricket match. Now, let's say there is a problem statement what we want to solve, but before that, let's understand what is this data in front of you. So, let's say India played 100 matches, and in those 100 matches, India won 60 of the matches, and India lost in 40 of those matches. Now, in all those 100 matches, the player Sachin Tendulkar plays, and it is being noted that Sachin Tendulkar hit in century in 12 matches. In 88 matches, he could not hit a century. But in those 12 matches where he hit the century, there were basically in the 10 matches India won, and in 2 matches India lost. Similarly, in the matches where Sachin doesn't score a century, in that case India won 50 of the match, and basically India lost 38 of the match. So this is how the data is. Now we want to basically compute here that what is the probability that India is going to win the match given that Sachin is going to hit a century, right? So I'm pretty sure people from India will be very excited to kind of infer this kind of answer from it, that how we can determine all those things. So that given that India Sachin is going to hit a century, then what is the probability that it's going to basically India is going to win the match? Now, if you look at this data, basically we have few things to importantly look at. So we have to define A and B, right? So let's say my A is that India won. A means India won, and B event means that Sachin hitting a century. Sachin century. Let's say these are the terms which we are going to define. Now, if I ask you in simple word that what is the probability that India is going to win, you can very easily compute that. So you would say probability of A means India is going to win is going to be 60 divided by 100, right? And what is the probability that Sachin is going to hit a century? You would say probability of B. Basically, Sachin have hit the century in 12 matches out of 100. So it's going to be 12 by 100. Okay, this is simple, no problem. Now what we want to calculate here, we want to calculate what is the probability that India is going to win given that Sachin have hit a century. Now if you intuitively want to see this answer, this is basically a conditional probability, right? If you intuitively want to answer it, and if you remember what we have learned from the last chapter, we look at the sample space where B belongs to now, right? We don't go to all the sample space. Remember that example of dice? The same thing we're gonna look at. So basically we look at the sample space of B. What is B? Sachin hitting a century. So Sachin have hit the century only in 12 matches. So this going to be into my denominator. Now, what is the probability that event A and event B both have happened now? Means India have won and Sachin have hit the century. So what is that part? It is basically this time. So remember from the dice example, we were looking at all the common part where 2 have also occurred and the sum have also occurred, sum less than equal to 5. So this is going to be 10. So intuitively from this table itself, you can very easily compute that your probability that India is going to win given that Sachin is going to hit a century is going to be 10 by 12, right? This is a very simple straightforward stuff. Now this is your conditional probability. If I had to calculate, let's say, a joint probability, joint probability means what? Like I want to compute which actually I have already put here intuitively, this term, right? I was already putting it here, but let's basically make it more concrete because that was not actually concrete thing. Now here basically when I was saying that probability that event A and event B both have occurred, what does this mean? Probability that India won and Sachin have hit the century. Can I say 10? No, we can't say that, right? So this is basically what we are trying to do. We are trying to get a joint probability. What does this joint, why I'm putting comma? This comma actually also can be represented like this. Means I could have also said intersection. Okay, some people write like that, some people do write like this. So what is the probability that India won and Sachin hit a century? If you go back, this is basically 10, and from what sample space I'm talking about? 100. So basically here we will be getting a joint probability of 10 divided by 100. Can I say this is equivalent to probability of B intersection? Think about it. Yes, why not? I can also say this, right? That probability that Sachin score a century and India won is equivalent to probability that India won and Sachin hit a century. It's the same thing. If even if you go and look at a table and get the answer, it's going to give you exactly the same. Now, if you do remember, intuitively what we were saying that probability A given B means India won given that Sachin hit a century. We got the output as 10 by 12. But let's see if we would have gone with the exact way of calculating this, how we would have got that. We would have said here probability of basically A given B is basically here I'm going to look at first of all this intersection value, right? Now further to this, I can basically gonna define the probability that basically Sachin have hit a century in this basically space, which is going to be probability of B. It's going to be what? 12 by 100. 12 by 100. And now if you divide this, you're gonna get exactly the same thing. So can I define it like this? Probability A intersection B divided by probability B. Think about it, right? Can I write this? This is exactly what we have just computed here. Now, awesome. So what we have just got here, we basically got this part, and now I'm gonna bring this here. So let me note this down probably more clearly here. So I'm gonna say probability of A given B is equal to probability of A intersection B divided by probability of event B. Now this is basically the part, and what I'm gonna do from this now, I'm gonna define this exactly like I'm just gonna move this term to this side. So I'm gonna say probability of A intersection B is equal to probability of A given B into probability of B. Right? I can write it like this. If you put your terms here, you will also get your outputs exactly in the same manner. There is no problem. Now let me ask you a question. So what is the value of this? The value was 10 divided by 12, and if I basically look at this value, this was 12 divided by 100, and we were getting like 10 divided by 100 out of it, right? This is basically my output, probability of A intersection B. Now, if I define this term in a little different way, how about if I write this term like this? Probability of B given A dot probability of A. Is this equivalent or not? Let's compute and check that. So probability of B given A means probability that Sachin score a century given that India won. This is going to be 10 divided by 60. I would strongly recommend you to go and check that. So given India won, like, so if you go, I need to look at the sample space of A. Let's go and check that. Sample space of A is India won. This is 60. And both the event occurring 10 times. That's the reason 10 divided by 60. So by now, I hope everybody became already an expert into this calculation. Now into probability of A means probability of India winning 60 by 100. Now if you compute this, this is also 10 by 100, right? Actually, if you do computations like this for any term, you will get exactly the same output. So can I say here that probability of AB into probability of B is equal to probability of B given A, probability of A, like this part and this part. Can I equate it? Yes. So that means I can now use this term like probability A given B is equal to probability B given A cross probability of A divided by probability of B. This is another form of Bayes theorem. Okay, so we just proved it with this part that either I can say this exactly like probability of A intersection B divided by probability of B, or the other format which I just showed you up. So anything is fine, any way you can define this term, and we have just basically proved this thing. So this is basically what we are going to compute. This is basically we have just understood with the help of one example that what is this Bayes theorem looks like. So the idea of bringing that Sachin Tendulkar example was just to give you an insight that what basically how you can derive this mathematical thing from an example rather than deriving first this formula and then deriving an example. So I took a reverse approach so that you could kind of understand it a little better way. Fine. We will see now few examples to understand it even much better in the basically the next lectures. So what we're going to do, we will take some data set and we will see that how this formula is going to help me to get this conditional probability outputs.